for this workshop. I'm thankful for the introduction to Dr. Pramita. Essentially, I'm a machine learning professional, practitioner, especially. My interest is to solve problems with machine learning. I'm not uh, so much into the computer science of machine learning, though I co-authored few patents, but I love to use machine learning for solving different problems in science and some business areas as well. So, my current area of interest is drug safety, especially pharmacovigilance, identifying adverse drug effects from clinical trials, and knowledge of science, which involves physical chemistry and biophysics as well. I've created a tool to match FDA results and go beyond with microsegmentation of patients and the potential side effects, which I'll explain later on, not now. So today, I plan to talk about few subtopics in building agentic AI. At the end, I will show you a Python program. Everything else except this Python program is public information credited to the mathematicians and scientists, especially at IBM Technology, Anthropic, and few open source initiatives. At the closing, I'll encourage you to participate in an open source initiative led by Cisco. So that's the overall plan. So I will introduce the basics of AI agents, and thanks to all the other speakers and who introduced you right from Python initial uh, definition, discussion, writing programs. I thankfully attended two of them, and Dr. Arunava Adhikari, Dr. Obijit Korgupto, Dr. Kishore, and Dr. Pramita. I think all of you guys added so much of value in introducing the audience. And while this is happening in Bengal, West Bengal, and as a Bengali, I love to speak in Bengali, but I think there are some uh, people from outside Bengal as well. So I will now switch over to introducing few things, and which will create the base, and which will also create a little bit of uh, clarity around different terminologies that people use left, right, center. Okay. So let me go to my directory. I'll show you a few things. So I actually wanted to talk about this first. And there is a lot of confusion about, is generative AI same as AI agents? So the answer is no. So it's like generative AI is the stairs and AI agent is somebody sitting on the top of the stairs. That's the reality. So if you look at the generative AI and AI agents, and I have created a comparison. So the core purpose of generative AI, which differentiates any AI program, not AI agents, any AI program is to generate based on previous knowledge and a tokenization methodology. Whereas AI agent is uh, basically accomplishing tasks. So one thing is 100% sure that these two are related, okay? But one is not a subset of the other, and one is not a superset of the other, correct? So if we look at the differentiation that I created here is generative AI actually creates content. AI agents actually does tasks. Operation mode, if you look at it, generative AI single turn response. So you go to maybe Claude or maybe to Gemini, and then you can type something saying that, okay, what is the possible outcome of West Bengal election 2026. So if you type this to generative AI, it will, and I've tried this honestly speaking, become interested Bengali. It says election has happened on results will be out on 4th of May. Here are the trends. Nothing else it says. Okay. Thankfully, it did not hallucinate and say, okay, X will win, Y will not win, etc. But there are situations where it can even come back and tell you that X will win, Y will not win. And honestly, I tried few physics related queries there. I tried something like I defined a collision and asked them to create a Feynman diagram. And it was a disaster, honestly. But now I think over the last few years, it learned a little more on that. And AI agents is a multi-turn autonomous loop. So if you ask AI agent to do something, it plans and then retrieves data, connects to different databases and sources, and then execute, and then uses a RAG model to validate that this is okay, and then come back to you and give you the result. And it can automatically, autonomously run. So while I'm talking of this, I could not resist saying that the Security Operations Center, the SOC, you might be aware of this, that in cybersecurity world, uh, every company is protected by SOC, Security Operations Center. And nowadays, and I'm associated with one of the companies in Bay Area, that they have built AI agent based autonomous security operations center. So that's exactly what a AI agent should do and should be used, right? And a generative AI cannot do that, because generative AI, what it could do actually in this area is that it could take some, and it does actually, it could take some threats and converts that to in English description, saying, hey, you know what, this is a malware, and this malware uh, can be stopped using these tools. So that's what the fundamental understanding between generative AI and AI. So I'll share all these documents with you guys. You don't need to take a note. You just listen. If you have question, raise your hand at the end. So a typical generative AI is ChatGPT, Claude, and AI agents is like somebody, and I saw someone to do that. And they were planning to visit Greece. They did the whole itinerary using AI agent. Okay. And they even booked the flights, booked the hotels to AI agent. So AI agent is more performing, accomplishing, rather than generating new content. And generative AI is all about generating new content. So I think I have told most of this. So, but I'll still go through this slide quickly because we have limitations on time. And so generative AI is primarily based on, and actually is completely based on foundational models like LLM, large language model, and in certain cases based on SLM, small language model. And I'll probably sometime if I get, I'll talk about how SLM is getting more and more popular in this business world, not so much in academic world. Response based on its training data and current prompt. So, for example, and this is a funny example, and a lot of my friends laugh at me because of my bias towards certain political ideas, that if you train um, an engine, and we have tried this, and me and my son, we made fun of that, is that we train an engine with so-called truth, and very different from the real truth, about Indian history and Indian independence movement and some party's role in 1942. And, and those parties probably now claim that, I mean, they were the people who served Bengal. Anyway, so the training data was that, and the prompt was completely, the prompt we were doing was generating completely misleading information. So what you feed and what you train the data on, so it comes out, right? So don't misunderstand one thing. Artificial intelligence is artificial. It can only learn based on the trend and the data that you shared with the engine, right? It does not have a persistent memory, and it's independent and stateless. So you want to write, and I tried this. I tried all of these, and I'm sure most of my friends and you guys tried the same thing. I tried generating documentation, saying if I ask, and I did that. If I ask ChatGPT to write a story in Shakespearean English about my college life love story, it wrote a fantastic story, and I could not recognize that the actors were, including myself, and the story is not written in Shakespearean generation. It's absolutely in that English, so it can understand the trend and the tokens. And I'm sure you guys understand token. If you don't understand, text me. I will tell you about the token thing. On the other hand, so what is AI agent? As I explained a few minutes back, that AI agent also needs to work on an LLM, and it also needs to work on a generative AI. Now, later on in another slideshow, not slideshow, basically a document, I'll share with you guys how the whole architecture of AI agent works. So, AI agent is, again, as I said, is autonomous. AI agent is also initiated by a prompt, right? Because you need some parameter to be passed to do certain actions. An AI agent is action oriented. It's a list of or course of actions that happens one after another, right? So what it does is it takes your comment, which is probably a prompt, and then breaks it down several tasks, then perceives, and then reason with its own LLM and with its own knowledge about the subject. Then it acts an observe loop, do a self-correction using, mostly using RAG, honestly, and then delivers you the result. In many cases, I'll make it a little more complicated because that gives you an idea of how in life it works. Suppose you create an AI agent, and that AI agent will basically function on your, say, employee database. Very poor example, business world. You go to ChatGPT and tell ChatGPT, and this is the differentiation. You go to ChatGPT and say, hey, you know what? Tell me how many vacation days I have so that I can take my son to fishing, right? So ChatGPT, mind it, ChatGPT never says no. So it will come back and say some bizarre responses. But if you really want the answer, you need an AI agent which should have access to a LLM, which gives them an idea. It helps in planning, gives it an idea, saying what is a vacation day, right? What do you mean by vacation days? Okay, is it like public holidays or it is like accrued leaves? So it has to understand that from the LLM, and make a query to your company's HR database, get an access to your record, okay, as a super user. Maybe sometimes it may be blocked using because of Microsoft Purview or Okta or something like that, but it will have to get an access to your particular record and come back and tell you the answer. Say that, okay, you have 12 more days available and you can take you will accrue the leave and you can take the leave in the month of June. So that is an example, right? I will show you guys at the end that I have written an AI agent which can retrieve set of research papers from PubMed, which is a very well-known biology um, and computer science and healthcare research repository and publication um, managed by some US authorities. Now, mostly NIH has National Institute of Health that has the control over that. So that agent generates you all the list of papers or retrieves the list of papers from PubMed. So that's an agent. That's not a generative AI. Now, as I told, key reference, so single shot loop, if you look at it, does you have defined the goal, it plans it, acts it, observe it, replan it in an iterative manner, and gives you the result. It can run on auto mode also. You can set up a PubMed tomorrow, and I could actually modify that, saying that PubMed, this agent, sit on my desktop. Every time there's a new paper in this subject, send me a message. So it will automatically, autonomously work without any specific additional inputs. So if you look at it, uh, LLM does not have a tool. It has a foundational model. It has access to a lot of data, billions of tokens. Okay, token. I'll give you an example. Suppose I say I love. What is the next word? It will do a probabilistic analysis saying if people say I love, does it say I love you, I love food, I love flower, what it is? So it tells you I love you and it ends there. No, I want a sentence a little longer. So then it will find saying I love flower, especially rose. All these specific words or texts or tokens chosen on the basis of statistical probability that happened in the past. So this probability calculation is based on the usage which happened previously. So that's how tokenization is. Anyway, so going back to the AI agents, um, AI agent has to have a web search methodology. It has to have access to APIs and database. It should have a code, and it has code execution capability, a file system to store and handle data, and some specialized agents. And there are AI agents. Actually, generally, I forgets everything. You know, after if you look at the original generative AI tools and ChatGPT 3 or 1 even, I've used one as a beta customer. You ask a question, it gives you an answer. You ask the same question 2 days later, it gives you another answer, right? So it doesn't keep anything in the memory. But AI agents maintain memory because based on your queries, it also forms profile pattern of yours, saying, hey, when Rathi Dasgupta asks questions, and if it is about physics, he asks questions on these subjects. So let's refer to those APIs and databases when he asks a question. And so it has the in-context memory, which is used in the current conversation. It uses a scratchpad memory, which is working memory, and it also uses a long-term memory, which I just told you. So it forms a pattern. So, so this is a diagram, and I'll share with you guys. There's no hurry in copying. So AI agent basically needs generative AI or LLM core for reasoning, language, and planning, and then needs memory, tools, loop, and autonomy. Autonomy is the key word. So it can work on its own. Okay. So there's a lot of things here I will probably go through, you guys. Um, Dr. Pramita, is it okay if I answer any question already there from the audience?
Is there any question?
Yeah, if not,
Sir,
yeah.
in your screen, it is like a pop-up screen shown in the right side top.
Okay, let me see. Okay, okay. Mm, so is it coming like in the form of a? I cannot see that actually. Anyway, so
Okay.
if there's a question, and what you can do, two things. We can answer all these questions at the end of the so-called lecture, and then the other way around is you can send me all the questions and I can give you detailed response. Okay, so I'm just going back. Okay, so
Sir,
yes,
can you minimize the pop-up screen which is showing on the right top?
pop-up
Because
screen showing.
yeah, because it is blocking some portion of the screen.
When you
Okay,
see the screen,
huh.
it is showing in the right side top of the screen.
Oh really? Which one? My document.
No, not your document, but some screen showing your presentation and something.
Something.
But your
Okay.
but your presentation is okay.
Huh.
Maximum portion of this covers your presentation, but on the right top, some
Okay.
pop-up screen.
Oh really? Let me see. Let me see.
Yeah,
Oh, that
yeah.
pop-up screen is
Yes, yes. You can
essentially.
minimize. You can minimize
Okay.
this.
Uh, this is actually our uh, conference. I mean, this. Does it look better now?
Yeah, might be.
Yeah. Can you just see that? Maybe. Yeah. So let me just. How do I do that? Is it okay now? Better?
Yeah. It's okay. It's okay. It's
So
okay.
it was the Google Meet that was creating. And now can you guys see it better?
Yes.
Absolutely okay, sir.
Absolutely.
No, that's fine. Yeah. Okay. And don't call me sir. I'm just another human being. My Dadu gave me this name Rathi, and I was not born with a doctorate, so Rathi is fine. So anyway, so this is another document which I created again, based on public information. None of my um, U.S. parents have been infringed. So this is a document which I'll share at the end. So agentic AI is. I'll take you guys to the next thing, how to build step by step. So agentic AI and its structure I told you a bit, but this is how um, in detail the core components of agentic AI system. Okay, so first of all is the perception model, and um, agentic uh, AI needs a stronger, uh, a bigger, I would say, a foundational model. Like LLM is sitting on the top of a foundational model, right? And the difference between uh, an LLM and modern LLMs, and then nowadays in the modern LLM, you can add any file that can be in the form of uh, machine code, that can be in the form of images, video, whatnot, right? So that was not the case earlier. So the foundational model uh, could only take text. So now in the um, agentic AI era, we need foundational models which are strong enough to accept anything. And if possible, I'll sometime today I will also show you how the LLMs work, how the LLMs and API they all talk to each other, right? So perception model actually uh, is something like agent sensory model, right? So it can process. It's like me sitting here in front of you guys. Unfortunately, I cannot see your face. I cannot see whether you are raising your eyebrows or you're saying oh, rubbish. None of these I cannot hear, right? But uh, agentic AI needs those perception. It needs the inputs, which can be text, images, audio, tabular data, uh, relational database, unstructured database, everything. And filters on prioritization relevant to the signals from the noisy input streams. So if you, it's very interesting, and unfortunately today you don't have time to do that. Uh, a perception module of an AI agent can um, identify a video actor in a marketplace if given the right signals. So um, that's the perception module, which is extremely important. It captures the data, takes all this data, uses APIs to get more and more information from any form of um, structured and unstructured database. Then comes the memory system. So uh, agentic AI, as I told you, it learns from your previous interaction. So your previous memory, which is called long-term memory, and which is in a way is a semantic memory, and it also have the which terminology. This science is full of terminology. So episodic memory, which is the previous interaction, log of the past actions. If it is generated something and I said doesn't work, modify. So it understands all of this from the memory system. And then the goal of the task manager. So it's high level prompt that gets decomposed and going back to, I'll give you an example. That will be good. Going back to the basics to formulate the strategy and then reasoning and the planning engine. So if today I ask a question saying that I want to know American president's tax return for the last 5 years, right? So if I ask that question to an LLM, it will give some gibberish answer. If you create an AI agent to do the same thing, it will come back to you ultimately saying that IRS bans you. IRS is Internal Revenue Services, like tax authority in India. IRS bans you to have an access to the president's financial record. It's not public, right? So that's the basically that's what the reasoning piece does, and it goes through chain of thoughts. It goes through reasoning and then act, and the reasoning and an act is based on the three thoughts. So that's reasoning and planning engine. Then comes the tools and interaction, which I told you a few minutes back. Is about it needs a web search and page browsing. If I ask it to do a web scraping and saying, you know what, find all websites where my name is mentioned, right? So it needs to have a web search capability, page browsing capability. It needs to execute uh, shell scripts, Python, retrieve data using SQL. It has to have a file open and file close and file read write operations. It needs to have API calls to several databases. Suppose if I say, um, what was the weather of Miami or say Goa, my most favorite place for vacationing, in 2022 January. So it has to go back to that um, database, weather database, and that's available on the cloud. It has to make an API call and then get cloud access to retrieve that data. So this is very easy to understand, this part. And then agent to agent delegation. I'll talk about that. That's very important. That an agent can be a solo agent. You ask it to do some work, it will only do that work. But in practical, an agent needs to have an agentic structure, and that we will talk about it. So let me ask you a quick. Let me tell you something. So um, that PubMed um, program which I have written, and I will revise that and I'll show you guys. PubMed, what it does, it takes an input from the user. User says, um, I want all the research papers in the area of pancreatic cancer, correct? Or lymphoma, Hodgkin's lymphoma. So it will retrieve all the data. And for that, this particular agent obviously uses all these APIs and web search and whatnot. Um, so it is a solo agent work. Now, if I tell the agent that I need the abstracts of those research papers, so it needs a separate agent, which is a retrieval agent. It's basically like Obijit uh, is working on a project on PubMed, and he knows that Rathi can uh, retrieve the abstracts because he has the access to these journals, correct? And can retrieve the abstracts. And so Obijit is the master agent. He takes the input, he does whatever he needs to do, sends me the list of research papers. Now it's my turn to use another agent to get an access to the particular journals, and then another agent probably to access the content of the abstract. And it can be made far more complicated. You can say, get all the research papers on lymphoma, Hodgkin's lymphoma, that has already conducted NGS, next generation sequencing technology, to identify a disease in a multimodal way. Now, so you can see there is a main agent, there are other agents working onto it with it. And there are different structures. You can have a hierarchical structure, it's called vertical agenting orchestration structure. It can be horizontal structure where everybody shares a task and does in collaboration, right? And you can think of something like your supervisor. And unfortunately, I had a um, research guide who was both a master agent and a collaborative agent. Binagda. Binagda is to formulate the problem, but also solve the problem. So that's exactly, you know what, all these agents, etc. concept came from human behavior. The way human works, it replicates. Agentic AI is all about that. And I'll later on tell you some uh, initiatives which I don't support, but there are people doing it to replicate how a human engineer will function totally from day morning 9 o'clock to day and 9 o'clock, right? And it replicates all the acts and functions of a individual engineer using different agentic structure. So that's what is called orchestration layer. So coordinating with the agent loop, different functions being differently uh, organized. So see the core. So what we do, one agent perceives it, plan it, act it, observe it. Then it calls other agents to help and do uh, sub-agent delegation. Does run few workflows. Suppose retrieval agent is one, which does a workflow. Okay. Now feedback, as you know, all of us being student of science, feedback is probably one of the greatest concept uh, which came from electricity, magnetism, right? Electrical circuits. Feedback is and self-evaluation, which is a very important thing that happens in a AI function. And the whole idea of RAG is generation is a offshoot of the concept feedback. I'll share it with you, these guys, and safety augmentation layer. So that's exactly I wanted to talk about the structure of AI agent. So how much time I have? So okay. So uh, let me do another one, and then I will go to the definition of, or not definition, is how agentic AI can work. And mind it, I will probably lean towards IBM's agentic AI framework because I contribute there as a open source initiative guy, and I I have not used um, much the Amazon Bedrock, which is also very useful. Just build one or two agents out of it. So this is another important thing. Concept is the how LLM foundation models API all get fit together. Okay, so um, the way it happens is the foundation model is the lowest layer, right? In terms of if you look at how it works, but foundation, I mean, how an agentic AI, how it functions step by step to get to the foundation model. So you have a foundation model. On the top of it is the LLM. On the top of it is the API, and on the top of it is the final agentic AI. Okay. So there is a structure on how the is it visible? Is it visible?
Yes,
Yes,
yes.
yes, yes, visible.
Okay, I'm trying to make it. Actually, I have too many documents and I'm trying to finish it up because I know it's getting late for you guys. But yeah, I know Bengalis do not take supper; they take dinner. So in America, people take dinner at 6:30 because of my uh, different physical ailment. I also take dinner at 7 o'clock. But the Bengalis take dinner probably at 9, 9:30, 10 o'clock, sometimes even 11. That's why I'm taking this liberty of talking a lot and spending time. So right now, I think you guys are at 7 o'clock or 7:16. So anyway, so coming back to this structure, this is exactly what I was trying to tell you. So at the bottom, at the lowest layer, where I have done some work, is a foundation model. This foundation model um, are um, the models that understand the trend. Correct? So, what is the difference between a machine learning algorithm or machine learning program versus standard program? So, the standard program takes the purpose of a standard program is to take an input, process it, generate an output. And what is the purpose of a machine learning program? And I have reservations about the word machine learning. Anyway, so machine learning program takes an input, knows the output for training purpose, and defines the uh, trend, defines the pattern. Essentially, does a very complex matrix mapping and uses that model, correct, for future usage. So if you give it all sorts of wrong data, it will create a wrong matrix mapping and generate all sorts of gibberish output. So anyway, the foundational model, if you look at it, is primarily pre-trained with huge data. That's why these guys are spending so much money on cloud rentals. Uh, it's a general purpose mostly because it has to solve different problems. Is transformer architecture, so you can use different combinations of machine learning algorithms. It is there's a lot of effort on reinforcement learning, and reinforcement learning, uh, in one word, is essentially um, it's like um, incentivized learning. Correct. So if you take your student and tell him that, you know what, if you uh, learn Indian history from um, Bipan Chandra's book, I will give you a brownie points. I'll give you probably two samosas, right? Or if you go to Amrita Pritam's book, okay, or if you go to Habib uh, Dr. Habib's book, I'll give you five samosas. So it's like you are incentivizing the learning. So if you look at it, the whole reinforcement learning concept is based on um, providing inputs and providing output and directing or biasing the uh, understanding of the trend through incentivization. So that's the lowest layer and very important. Without foundation model, the whole large language model will never exist. So if you now go to the next level, one level up, which is large language model. So you have a token prediction thing. I told you a few minutes back about I love you, or I love flower, I love Chingimach, or I love uh, Ilish Shorshe. All of these will come in with respect to, again, if it is Rathi Dasgupta, then these possibilities are there. But if it is someone like Ashley, Brooke, Calhoun, it will be probably pizza. I love pizza. So it is again context sensitive, and the context is environment, the total uh, input and the environment that you basically do. Suppose if you go to, and that's you can easily check it. You go to any large language model, log in from India, and search for political structure. Just a simple thing. It will give you mostly Indian political structure. If it is smart enough, it will show you, um, specific to you, the login that you have created. If I do the same um, query based out of Chicago, it will give you a completely different model. right? Um, so context is important. Token prediction is important. Uh, Large language model needs a prompt. Okay, then it breaks down and does embedding. And examples, as you know, are basically ChatGPT, Claude, Llama, Lambda, so many of them. And apparently, that few days back, Claude code was exposed, and a lot of smart people across the world, especially India and Eastern Europe, erstwhile Soviet Union countries, they have done lots of uh, Claude lookalike, uh, you know, LLMs, and so it is possible. And the moment you have access uh, to a code like uh, Claude code, you just need to figure out that your token prediction and your context and your embedding, these are correctly working, again by training. Next level is the API. So as as we all know, it needs to have the request and messaging protocol, which is HTTPS, HTTP, and authentication and rate limit. How many mm, how many papers you want to see doing that pub mode query. It will probably limit you to 10 initially. If you make it 50, then it has to do a different thing. But it does the authentication part definitely as a first step. So, in my previous example, I told a few minutes back that um, I have asked the pub mode to retrieve um, abstract. So, if I ask it to retrieve abstract, it will go through an authentication. It can be user authentication, it can be a role based authentication. Okay. One example of that is in a corporate setup, CFO has access to all the financial data, chief financial officer. And if somebody else wants to make a query to the financial database, in the modern system, what happens? A message goes to the CFO saying, people name such and such is trying to access the financial database. And it is happening because of a strong authentication server. And Microsoft Purview is one of them. So, and you can also write on your own. It's not a great check that nobody can do it. So, authentication is an important factor. Then comes model selection. Which model I should select, right? Is this model selection for audio, video, or is it like should I use Lambda? Should I use Llama? Should I use uh, Sonnet, which is by Cloud, or GPT-4 or GPT 4.5? So that is the decision that API has to take. Streaming output, obviously it has to. Uh, we used to do this many years ago in Sun Microsystem using Kafka, and Kafka is one of the things that we worked on. And Kafka is to do it even today. If you look at this API level, it's coded using Kafka. Then you have to look at the provider, whether it is OpenAI, Anthropic, Google, etc. And then last stage is agentic AI. So this is essentially the whole structure, or I would say layered functions to achieve and build agentic AI. Okay. So, and I talked most of this. I, I mean, this is an important data for you guys. Once this talk is
Rathida,
over,
one question maybe. Rathida,
yes,
can I ask
Abhijit,
one question? I'm
sure.
sorry, I may have missed something. What are those layers? Are those neural network layers or something else?
Okay. So
Are
neural
those
network layer.
hidden
Very good
layers of
question, Abhijit.
Rathida? Huh.
Abhijit,
Please. Yeah.
thank you for asking this question. That neural network layer is actually built in a foundation level model. So
Okay.
you have trained the system, you have trained the system to recognize, say, for example, a photograph of Rathi Dasgupta and Abhijit Kaur Gupta and our elder brother Orunabhu Odhikari. So it does a vectorization of our image, right? And then uses a neural network to say, okay, this is Rathi, this is Abhijit, this is Orunabhu. So neural network, if you look at the foundation model, is actually all about neural network.
All layers are there. Okay. Okay.
So,
And
and the way it happens is that you have a foundational model. Okay. Okay. Let me explain it in a different line.
okay. Okay. Carry on. Carry on. Please.
No. I have to answer your question because that's very important question. Otherwise, it looks like somebody is sitting on the somebody. Like first floor, ground floor, and second floor. Not like that. So, if you build an agentic AI, okay, you build an agentic AI to um, again going back to the same, probably a smarter PubMed AI that I have written is will be I create an agentic AI which sits on my desktop and uh, sends me um, daily message saying, hey, Roti, today these are the following research papers that has come out of um, that has been added to archive.org, right? And and that fits your area of interest, supersymmetric quantum mechanics or path integral formalism for coherent states, as specific as that. Now, the agentic AI to do this function needs to call several databases, right? So that calling is happening through API, right? Now, what does it call? It calls earlier, it used to call different disparate databases. Now it calls a large language model, right?
Okay.
So,
Okay.
got it. Now it calls a large
Okay.
language
Okay.
model
Okay. Okay.
because
Okay. Systematically. Okay. From
now the large language model,
top down. Top down. Yeah.
yeah, top down approach. The large language model um, has to use some um foundation model. So is it a question on text or is it a
Okay.
question on
Okay.
image or a
Okay.
video?
Okay.
So it
Okay.
goes down to the foundation model.
Okay, this is you are talking about process. I mean, the one from agentic, it
Yes.
calls
This is
API,
how
API
you
calls
also build
language
a
model.
AI
Yeah.
agent.
Okay. Okay.
So
Okay.
thankfully today, I have done it on Python, but thankfully today you can go to Claude and tell Claude to be an agentic AI for you.
Mm-hmm.
Okay. So then when it does the agentic AI, it does all these steps. It calls API, it calls LLM, it sits on the top of LLM. Then the
Okay. Get
LLM
it.
is based on the foundation model.
Okay. Get it. Get it. Get it. Thank you. Thank you.
Hmm. There's you can see the 4 layers of. So I'm not going, I've already spoken a lot about all of this, but so this is a document which can be useful for us. Okay, let me see. If there is any other question, please raise. Okay. So this is again a document which I wanted to show you guys for how you build an AI agent. No, this is not the good one because I created something initially and shared with you, Abhijit, which was I found it childish. It's like doing simple chemistry calculations, etc., etc., and doesn't make sense. So this is one I have created, and I don't claim any intellectual property. That's why everywhere I have mentioned the links. This is um, my capture of IBM Think AI Agent model. So IBM has again developed a AI agent model just like uh, Amazon has done it, Bedrock, just like um, Gemini is one. Even what is the other one today? Yesterday I saw. OpenAI has created a similar agentic AI platform. IBM is the father of all of this and created this long time ago. So I follow the IBM agents and I contribute to their open source initiative. So this whole presentation is based on my knowledge of IBM's agents. And there are very good videos if you want to know more on YouTube. There are very good videos you have um, on various learning sites. Okay, you can even go to ibm.com and find it. You can go to even Claude.com. So Claude has some free training courses, and you can learn from there. So anyway, so I'll talk about the IBM Think architecture, autonomy, anatomy, and the building. How do we build? So again, it really confirms to what I said few minutes back. So an agent is an autonomous program, and its core is at LLM. It calls different tools to enrich that function of retrieving, planning, retrieving, validating the output, and then send it to you. And for that function, it uses long-term memory, which is previous knowledge of usage. It creates in-memory context, and that is when it uses it, and it's something like if there's a database guy here, it's like staging database, So it uses in-context memory, which it erases after it is executed. And tool calling is all about, it uses APIs, web search, database search, and even other agent searches, correct? So I'll now change my example from PubMed, because you may have already developed ringing in the air saying PubMed is too much. So one of the examples that astrophysicists have been using it for a very, very long time. And some of my elders and friends use that in the University of Birmingham, University of Cambridge. So mind it, when you get a astrophysical image, so when you say you can see fantastic photographs, etc., right? Of the not the solar system, but the universe, right? There is a supernova happening, a star being formed, or two stars are colliding, right? All of these are visualization, and this visualization doesn't happen that somebody takes a camera and then takes a photograph. It doesn't happen that way. We cannot get that kind of signal, and these signals are very faint, feeble. So astrophysicists have been using big data for a very long time, I think about 20, 25 years. And what they did is that they collected all these signals coming. It's like they may be collecting spectral lines, they may be collecting photon concentration photographs, they may be doing a lot of other different technologies that we think of. They may be even doing magnetic mapping. And I'll tell you the interesting story later on. When I was recently speaking to a classmate of mine who works in University of Denver, and observatory, and she's a chief scientist there, ex Shah Institute of Nuclear Physics, post MSc, and um, she is trying to understand the solar flare behavior and its effect on the Earth's magnetic field, which obviously affects other things like Earth's internet connectivity, uh, Wi-Fi frequency. Everything gets changed. If there is a huge solar flare, then everything will be affected today. So anyway, so coming back to that, so they exactly are trying to create an LLM, which is very physics oriented LLM. So they're using a model called PIN, physics inspired neural network, as a foundation model. Oh, yeah, to answer your question. So they are
Yes, yes.
trying to create I mean, PIN is at a very early stage. They're trying to create a PIN as a foundational model. And then they will build an LLM, right? And they have kind of built a, not an LLM, but an SLM they've built, small language model. And now on the top of that, they will create APIs. And on the top of that, they will probably create an AI agent saying that identify any potential, probably some wish list, any potential black hole here, if you have detected. So that is how it will be built in future. And so LLM needs tool calling, needs memory and adaptation. So different operational stages how AI agents work. So when it is created, it has to be created with a goal initiation and planning. So suppose I use AI agent, agentic AI model. Um, Recently created one for, I mean, still in the process. We are trying to understand how we can differentiate between, and this is for the audience who has some interest in life sciences, how we can differentiate between Hodgkin's lymphoma and non-Hodgkin's lymphoma. Okay, and this is not just academic interest. This has tremendous impact on life, because if you treat a non-Hodgkin's lymphoma patient with a Hodgkin's lymphoma chemo, he or she dies in 8 weeks. Reverse is also true, but a little more. It's like instead of 8 weeks, it becomes 24 weeks. So it is necessary that you identify those things. So we are working on an agent on that anyway, based on the data, on the multimodal data. So when you create an agent, the goals and the rules are defined by people like us who will run and create that agent. So what I'm trying to do with using this creating agent, uh, using this agent, what is my goal? My goal is to probably create a journal search engine. That is my goal. And what do I uh, want to achieve in that? I want to achieve a much better, smarter search engine. Because if you go to Google and Google is, Google has made billions and trillions of dollars by providing search engine to the world, right? Now, even then, if you go to Google today and give a search about something, you give a search about Rathi Dasgupta, right? And you will see that there are, my name is very unique though, thanks to my Dadu. You will see there are pages and pages of Rathi Dasgupta. And that includes repetitive uh, retrieval, that includes Rathi separately, Dasgupta separately, that includes uh, even any Dasgupta doing similar work, that includes, uh, you know, wrong subtask identification. So it says Rathi. Rathi, there are some Marwaris who has last name Rathi, right? Rathi. So it will also do all sorts of definition around Rathi. Then Google identifies that Rathi did study physics. So it will do all sorts of things around physics being published, right? And I was surprised once I inaugurated a computer science department in a college in Bangalore. So when I do a search, it obviously talks about that inauguration. It also then diverts to find information about the college, which is not the purpose. The purpose is to find anything relevant to a gentleman called Rathi Dasgupta, right? So goal. So that's how Google even so smart that works like today. But so the agentic AI is far more specific, where you identify a goal, and the agent these days are smarter because of all this cloud and different LLMs and foundational model, that it can break down complex goals into subtasks. So when you are creating a agentic AI on your own, which you don't need to these days, you and using Python, you need to keep this in mind very well, that the goal and the rule need to be well defined. Then automatically the agent has to perform, and I'll show you that in my Python program. The agent has to automatically do the following tasks. So it can break down the complex task into subtasks, which is smarter agents can do. Then it can do reasoning. So if you run a agent code, and I can show you that. If you run an agent code on a like ChatGPT, etc., ask ChatGPT to create a agentic AI for you, you can see that it does break the task to subtask, and then it does reasoning with available tools, like um, it does validations, verifications of tools. It uses RAG, right, and validates it much better. So RAG is essentially you create a context, you create a sample result, and validate that against that sample result. That's in a very simpler layman terminology. That's what RAG is. And then it does the learning and reflection and generates the result that you want to. So this is the core. This is the core structure of agentic AI in the IBM Think. So you have the LLM at the core, as you know. You have the perception, basically the context setting, perception and input from environment. You have the short-term context and long-term storage, right? You have, if you have multiple agents, you have agent-to-agent human interaction, communication, as I told you, agent orchestration. Then obviously the learning methodology, which is based on feedback and the loops and refinement. Then tool calling, as I told you a few minutes back. Then reasoning and act, and reasoning and perform, two paradigms. And then task decomposition and subtask. So if you look at it in this fashion, whatever way you want to go, clockwise, anti-clockwise, these are the functions. And these functions are, if you go clockwise, then you use perception, planning, reasoning, tool calling, learning, communication, uses memory, which is not in sequence. But these are always back and forth thing. And essentially uses the LLM code. So when you create the perception layer, it goes back to LLM code to validate the perception layer is correct or not. Okay. And suppose, not a right example, enlightened audience like this, but there are bad people, right? So they do obscene search uh, for agentic AI. It goes back to LLM saying, is this within the purview? So LLM, uh, when it captures such senses, it completely stops it. It says this is not accessible. Okay, but I'm hearing now, unfortunately, there are agents which even does that kind of thing, uh, which is not good for the society. But anyway, so this is the structure. Any question, Abhijit or anybody? So if not, I'll just move in. So this is how agents think and act. And when I first learned this, I thought, like, well, I do the same thing when I think, right? I do reasoning and then take action. Sometimes I don't do reasoning and don't do observation. I do reasoning, but without any observation. I can just, I understand the reason, blindly tell this, without understanding that um, it is not fitting the observation. But both of these are useful. Both of these are very useful. Um, so react. React is nothing but reasoning and action. Okay, it's not react, but reasoning and action. Um, Agent reasons about the current state and decides on the next action. So that's when it goes to the next action. Is actually it's in the planning stage. Agent calls a tool or takes an action in the environment. Agent reads the tool response and updates to the context. So when you do a step-by-step problem, where the transparency of reasoning matters. So, for example, you are uh, again creating a agentic AI to solve a say, for example, what do I say? Something more intelligible to people here. Mm, Most of them, I think, are physicists and sociologists here. So, if you really want to understand um, what is uh, the impact of recent war on Indian economy and how it affects uh, not the marginal people, they are always affected. They are the mercy of the whole world, but the middle class, upcoming middle class in India, right? Now, uh, you have to choose the right context. So, this is a step by step problem, okay? And you want to see every step of this transparency of reasoning. What do I define when you say that there is an international catastrophe? Is it a catastrophe? First question. Then, what is the impact result of the catastrophe? You want to see that. And how does this catastrophe interact with the Indian economic system? Now, Indian economic system doesn't only mean the stock market, right? It means it doesn't also uh, tell you about the inflation, because inflation formula can be tweaked and its statistics in a way so that inflation is only shown at 2%. The relevant information, if you look at middle class, the relevant information of this upcoming software engineer middle class is they buy houses, they buy uh, cars, they buy recently launched television, etc., etc. Now you want to see how that market is being affected, because they don't have they will still buy because they have some money in the pocket, but what will ultimately affect is the disposable income because of the high cost of product, right? So that is essentially one step-by-step problem which needs transparency, and you need to understand whether it is actually going right. Because the system can give you all sorts of nonsense, gibberish answer, because it is not trained to analyze this kind of thing. So you need to really create an agent rather than go to LLM and ask this question, right? And other one is reasoning without observation. So how can you when can you when can you use this one? Where you are trying to reduce the cost of implementation. So essentially, you are reducing the token usage. You are avoiding too many interface of calling tools, AI tools, right? And making too many IO calls to different systems, right? And that can enable plan review by the human, right? So it does anticipates all required tools upfront, no waiting for outputs. Whereas in the React, it doesn't know or doesn't anticipate or take for granted the tools. It in Ryu, which is reasoning without
Rathita.
observation. I'm sorry, but
Rathita.
well,
Yeah, I'm interrupting. Two questions. One is
tell me.
where is data here? Is observation in Ryu on right side?
Hmm,
You say reasoning without observation. What is this
correct.
observation? Is this data or data is in the previous levels?
So no, data will
Here,
come
anywhere is
much below.
data. Data is in the previous I mean, in the foundation and other levels, LLM levels.
So data is at the
Here is
okay, good question. Because data is
what
at
is
the
this
LLM.
observation then? What is this observation? Observation means we mean something, some data. That is observation, right?
Correct, correct. Observation
What is
means
observation
Obir,
here? Huh.
it does not really validate against a similar result. It it is like in Bengali we say Shobjanta, sort of. So it
Mhm.
assumes and anticipates the tools up front. You need to do that for very commoditized thing, right? So if you go to want me to create a Java program, for example, to create an interface, it's being used. It has been done probably billion times, right? So it knows what it has to do. It doesn't validate it. Doesn't do the observation and validation. It knows it can be done. So it collects all the tools, doesn't make too many uh, tokenization calculations and usage. So it doesn't use a lot of token. It knows how the tokens will plan it, right? So it
Okay.
knows that you create a UI with Java, you need some
Okay.
databases which are there, and you need a middleware to validate the rules. So it's a
Okay.
simple
It is
three-tier
it is
architecture.
it is manipulating in the higher dimensions in the where the tokens live.
Pardon?
It is then manipulating things in the higher dimension where the tokens live, right?
Yeah, it's. I would say it's sort of a. Uh, uh, it's
Is
sort
a
of
higher
a
dimensional, is a hypothetical higher dimensional
correct, but it
space
also
where
goes
the
down.
tokens are
It
there.
doesn't
It
use. It
monitors that
doesn't use
token.
foundation model so much.
Okay.
So it uses because it doesn't do much of observation validation.
Okay.
You can see it collects all tools outputs in single batch pass. It doesn't go in an iterative manner.
Okay.
Got it?
Okay.
So
Okay. Okay. Partly.
one
Yeah. Go on.
example will be
Hmm.
somebody is doing a simple classical mechanics problem,
Mm-hmm.
right? Maybe collision of uh, particles. Now, there's nothing new that can happen out of the calculation, right? So it knows what is the kind of differential equations that we need to use. It directly goes to that equation, um, single pass. It finds the answer and meets the conditions of the plan, and then give you the result. But if you want it to do something which is probably a nonlinear scenario, it may fail. Review will not work. So you then need a React. Even I think React will also fail, but anyway. So, but React is actually far more useful.
Okay. Observation means here it is monitoring that all these things. Okay.
No, observation
Or
here
reaching
means,
to
Abhijit, it's a
Mhm.
the fundamental. Uh,
finding out the relations or something, right? Or
no,
where to
it's
reach.
fundamentally. I'll tell you something. In a in our language, it means that it understands the mapping.
Okay.
It does the
Okay.
mapping once only. It doesn't try different mapping and say which one gives me better results.
Mhm.
Got it? So that's why I give you that classical mechanics kind of a situation. Classical mechanics can also become very, very tough if you add so many other factors into it. Obviously, very difficult problem. Um, you remember that Vijayada used to um, add different complexity to a simple problem and show how it changes the pattern,
Yeah.
right? So the skeletal problem that Vijayada knew, and we all knew the solution, is something is a Ryu uh, way it works. So it knows what path it has to take, and it does do the calculation. Correct? It does the calculation. Single batch. It doesn't go back and
Okay.
forth.
So, do you think that the two methods both are human thinking, closer to human thinking, or which one is
Very
closer to
much.
us?
Very much. Very much. If you
Okay.
ask me today that, uh, Rathi, um, tell me about what is the eigenenergy of um, um, harmonic oscillator, simple harmonic oscillator, right? I mean, quantum harmonic oscillator. I'll not even think, I'll tell you the answer. But if you say that, Rathi, it is not that, I'm asking you to a scenario where the harmonic oscillator is in an environment where there are random noises around it. I'm gone. I cannot answer so easily. I have to do all this calculation, reasoning, add constant equation, automatically solve the problem back and forth. And that's what is React.
Okay. Please carry on.
I know
Because
physicists don't
yeah,
understand unless
we'll
physics is
React
involved.
will discuss later more. Okay, carry on,
We
please.
will, we will discuss. And there are, even today, there are people writing patent applications, which I don't like filing patents. People writing patent applications on both of these think and act model. So there are 5 types of agents: simple reflex agents, condition, and action. There are model-based reflex agents like perception and memory, maintains an internal world model, handles partially observable, changing environment. So, um, example, and I had one which I actually threw it out because of too much noise. Is a robotic vacuum instrument. You know, Amazon and everybody advertises all the time. So, robotic vacuum, how does it work? Have you ever thought of it? It uh, first moves around the area to create a map. And if you see the app which is on the phone for the same vacuum cleaner, you will see that it has actually created a map and identified its lat long. Okay. And now it starts. Um, now it starts cleaning the place, visiting the place. Now uh, it has an understanding of a model saying, I will only clean areas where there are more dust particles. That it doesn't know that time because it's just a map, the GPS map, which is based on Wi-Fi. It has created. but it will know the areas where there is no. It will identify there is no dust particle here. It will just speed up there and go to the next level. Speed up there, go to the next level. So it is basically a model based. Already the model is defined. The data has to go, and step by step you have to identify the map. You have to identify, then start working. You speed up where there is no dust. You go and do a repetitive dust cleaning. In some cases, it goes there, and I've seen that. I did that experiment. I put a lot of moody there. You know, all Bengalis knows moody. So, and I have plenty of that at home. So, I put extra moody in some area. It goes there, picks it up, and then comes back again. Picks it up, then comes back again. When it ensures there is no additional moody left on the floor, it goes to the next level. So that is a model-based reflex where the model already knows what to do. Then the goal-based one. Okay. So the goal is to suppose all the GPS systems are basically goal-based, agentic. If you use a agentic AI to make a goal-based one, so you want to go from, say, Raspberry Avenue to Jodhpur Park, right? And I don't know how many of you are aware of the Calcutta maps. I can close my eyes and draw any map any day of Calcutta, any street. So that's a good thing I have. So you can go through same Raspberry Avenue, follow Raspberry Avenue, go to Goriart Junction, then take right, go through that Goriart Road, go all the way to Jadavpur police station, take right, and go get into Jodhpur Park. Or you can take a right halfway through near the Jodhpur Park post office, or you can have several things, right? Several paths. Now, there is a possibility that as a physicist we can do a path optimization, right? Simple. But which one takes fastest route to the destination? But then the GPS tells you that there are obstructions in some of those paths. This is a procession, which is typical of Calcutta. There is accident, not so typical. And there is some road construction which benefits the corporation. So all of these extraneous constraints are there. So if you look at it, the goal-based one will probably generate the delta of path equal to 0. I mean, minimum path generation it will do. But then it can understand the other constraints. That's what it's a smarter. It's a goal-based and I would say learning-based model. Both of these together can give me the solution to the problem which I was trying to solve. To find the fastest route from Rajbari Mode to Jodhpur Park, because you can also go through Southern Avenue and then through the lake, or you can go to Southern Avenue and Gold Park through the lake. And there is a right road next to the Ramakrishna Mission. That is one way, so you cannot go right. You have to take a road before that next to the lake. So there are so many paths it can choose. And it can be based on what is the goal? Is it based on minimizing the time? Is it based on, that's the goal, based on minimizing the distance, because then you spend a lot of petrol or diesel, whatever you are using. So it is basically goal based. Then comes the utility based. So that's what I told you. The utility based is the next one, which tells you the optimized path. The easiest one is goal based. Utility based is on the other thing. Just like when I drive, I use a product called Waze, WAZE. And Waze is a product which runs on agentic AI, utility based agentic AI, and based on crowd real-time crowdsourcing. So if I see a police nearby, I will press a button. So that goes to the system, says, to the next driver that 300 meters, the cop is on the right, on the shoulder. Please avoid. So that is basically a utility-based example. Learning example is this we have done several times. Um, and everybody does it. If you go to Amazon, you will log into Amazon. Amazon will tell you recommendation for you today. So personalization recommendation. So what it does essentially is looks at your buying patterns, not just what you visit, okay, but what you visit and buy. It also does check your pattern where you um, did not complete a total purchase, right? So it sends you a message saying you left this transaction unfinished. Okay. And all of these, how can it understand this? Because it has autonomously learned the new experiences of a new guy. Amazon knows Rathi Dasgupta because this fellow has been buying books since 1995. But Amazon doesn't know um, probably my niece who lives in Shantiniketan and tries to buy a book. Unless he impersonates and log in at Rathi Dasgupta, Amazon will learn now the mm, buying pattern of that little girl and will, again, mind it, it's a learning based. It will immediately identify this is an early youth. So it will push that early youth generating very general recommendation. Then it will start learning in the parallel, saying, okay, so mind it. So here is the complexity. It knows that this girl is only 16 years old. So, and from a enlightened part of Bengal, okay, I'm not saying everywhere in India, they're not enlightened, and that's not the purpose of this statement. But it classifies you that way. And I know for sure because I have a lot of friends in Amazon working on this. So, Obviously, again, you can see the validation. So it automatically generates a list of recommendation. Now, that says validation baseline. Now it says what this girl is buying. Is she buying what she is supposed to buy? No, she is buying something else completely. She is probably buying book which is on science or on Indian history, which is not expected. This the kids never buy such things. They'll probably go for cosmetics or something like that. So generic model and then validation against the generic model. So that's what the learning system. They're very fast learners, and e-commerce um, is one of the areas that learning system uh, works very good because this um, has to learn very, very quickly based on the baseline. Without baseline, you cannot learn. Okay. Now, I told you all of these. I've told several times. So these are the learning agent, results I have taken care of. So these are, again, the IBM thing has the same structure. It is a user interface, means input goals, orchestration layer, as I said, multi-agent orchestration, LLM, tools, and Hebrew knowledge base. So LLM is the center. Everybody else is messaging and communicating with it. Now the word messaging is not loosely used here. Um, messaging messaging concepts came in early 70s when IBM created something called MQ, message queue. And when I pass a parameter, That's messaging, one-way messaging. When the parameter, after going through a engine, comes back and sends me a result, that's also another messaging. So if a message queue is all about multiple messages addressing the same server, right? So messaging is that. I just digressed a bit, told you that. Um, Also, I discussed this multi-agent hierarchical systems. This is what you need to know. Now, orchestration, as I said, and I think, does it have the thing? No. So, or as I said, that there can be a hierarchical agent structure, you know, and there can be, a few minutes back I gave you example of my professor, and there can be uh, vertical structure which is hierarchical. There can be horizontal structure where each agent has different component. Now, if you see an orchestration agent, there is a search agent which does all the search, web data, etc. There is an analysis agent. There is a domain agent. There is an action agent. Now, how does it work? The main agent, orchestrator agent, it receives the request. Okay, that Abhijit Kaur wants to know um, semi-solid uh, particle research in today's environment since 2021 until 2026. Correct? So that's the problem. Orchestra agent picks it up. Now, what it will do, it will immediately pass it on to the search agent saying what data retrieval is necessary from the website. So it goes to archive.org, it goes to uh, IOP.org, it goes to uh, Journal of Physics, which is part of IOP anyway. It goes to all the PRL which is relevant, etc. So this search agent does that part. Okay. Then it passes on to the analysis agent, saying whether the data is right, whether it has captured really the semi-solid one or the solid one also, whether whatever he wants to, whatever his criteria is does it match? That is analysis agent. So this is collaborative. It can go back and forth, mind you. Analysis agent says, uh, sends a message saying, okay, the data is not right. So it will do again. It will run the whole loop again. And then domain agent, which is specialist knowledge. In this circumstance, probably um, uh, semi-solid physics is the domain. And the action agents. It has to call APIs and then ultimately execute. Right? And what are the shared stuff into it? So this is a horizontal example between search engine agent, analysis agent, domain agent, action agent. Whereas this is a vertical example of orchestration, orchestrator agent, and all these agents together. Got it? So this is a multi-agent scenario where we have both horizontal and vertical architecture, right? So it obviously does much greater performance. It does a validation of information which comes in, and it definitely um, minimizes back and forth communication between the agent and the human. So, you know what? You may have heard this word these days. This is like a catchword said human in the loop. Human in the loop means there is, suppose there is one person sitting here and then running the agentic AI and in orchestration structure, and uh, the results are given. It He validates and say, "Oh, this is not good. Revise," and then it gives the results. And no, this is bad. Modify this. So that if you look at it, that human in the loop action is minimized by this analysis domain action agents. So that the search agent goes back and forth in a loop. right? Not an infinite loop, but in a loop. So that reduces the human input. Any question? Anybody? Abhijit or Kishore? Okay. So I've
No,
already chosen.
okay.
বলো Abhijit?
ঠিক আছে, okay, it's okay.
Okay. So, and now if you have any question which can help all of us think better, then obviously there has to be a question. And orchestration, agent orchestration is very important factor. Suppose you had no analysis agent, a domain agent, just search agent and action agent together merged, then obviously human in the loop is a lot more. And obviously, every time the human in the loop acts, uh, the cost of tokenization goes up, right? Because it again reinstates all the different functions of the agent to work on. So this is again, I told you so many times, probably it's ringing in the air. So AI agents are applied. IBM has um, very good AI agents being applied in customer experience, healthcare, emergency response, finance and supply chain, all of these domains. One example each is customer experience. You go to the AI agent, the bot, okay? Not the standard bot. This is AI agent bot. So you are in the airport, you have your phone, you go to the bot and say, where is the nearest bookstore? Now, probably in a decent country, in a decent airport, there are at least 3 bookstores. Okay. One may be a coffee bookstore, etc. So if it is bought, it will ask you a question that you want bookstore or you want coffee bookstore. So AI agent will never ask you that question. It will not. It will it has already understood you because you are using it. It is sitting on the top of your phone, right? So he knows you are only looking for a bookstore, not a coffee bookstore. Okay, not a CNN agent bookstore, which are there, 5, 6 agent bookstores across um, the airport normally. So it will send you 3 different bookstores address with distance. You're saying one is at 0.7 mile, one is at 0.1 mile, one is at 100 feet. And then also the information, 100 feet, what is that? Is it a fiction bookstore or is it a serious bookstore or whatever it is? And it also tells you the path. So you click, it then invokes the GPS engine and gives you the direction. Okay, that's a customer experience agent. Healthcare. Healthcare is like it's tremendous. There's so many things, right from the area where I work, drug safety and drug discovery to, that is life sciences, not so healthcare. But healthcare, one example which you guys probably are not aware because they're no doctors, which I learned working with the doctors at UIC, is that whenever there is a surgery that is scheduled, right? A surgery. I had 5 surgeries in the last 2 years. So whenever the surgery is scheduled, uh, always understand one thing. If you go to a hospital and you have a surgery, mind it, the whole surgery is not just one surgery. Who are the actors involved? There are consultant doctors. One does the surgery, one does the initial opening, incision, one does anesthesia, right? So these are 3 different agents coming from 3 different organizations, not the AI agents, the human agents. And there are nurses, okay, the dressers. There are equipments in the surgical OT, operation theater, that these equipments, mind it, equipments are all on lease, right? So if you have planned for a surgery, you're supposed to come tomorrow morning at 6 o'clock for the surgery, and if you do not attend it, it's a huge loss for the hospital. So nowadays they are using not so much of AI, isn't? I think it's a misnomer. It's probably only for one or two hospitals, but they're using AI programs to understand what is the possibility of this surgery to happen. And in the US, if a surgery does not happen, that's a loss for about $25,000 for each surgery not happening. So hospitals cannot take that risk. Another example, uh, um, pre-approval is not a standard process in the US. Recently, I had a cerebral stroke. I walked into the hospital um, somehow, and then they have to take you because whether I can pay or not pay doesn't matter. They have to take you. That's um, the US standard. Um, so I was taken in. I was in the ICU. Lots of doctors, patients. I mean, surgeon. Then CT scan, MRI, all sorts of things, injections, nurses care, medication. All of these happened. Now, um, and there are systems, AI systems, which can um, tell them my survival chances after that attack, and according to that suggested procedures. So when I went back home, they have to now generate a bill which will go to my insurance company, right? And that's a very complicated situation. It's not easy because ICD-10 codes and the insurance company's policy and my level of policy, my coverage, my out-of-pocket expenses, all of these factors need to be considered. And it's a strong um, calculational process and lots of mistakes. Um, Someday when I get a chance to talk about it, it's an interesting subject, not so interesting as physics, but interesting, useful for patients. So I came back home and got a bill, right? How did I get the bill? Because um, this is not a regular situation where I go to the hospital and say, you know what, I have a ringing ear problem. So they will see that and say, okay, let's schedule a surgery. And you know what, the bill will be $16,000, of which your insurance will pay 15,000. You will pay out of your pocket $1,000. Are you okay with it or not? So even if I say and don't pay later on, that's a different thing. But I'll probably say no. So when this happens, they have gone through a pre-approval process, right? So that pre-approval process is again a very complex process. Is something like a multi-agent system can do. Okay, so or even planning for an emergency situation, like when I was taken in the stretcher, somebody has to get a stretcher, right? Somebody has to inform the nurses. Somebody has to inform the doctor. Somebody has to uh, immediately act. A nurse came in and you know gave some injections on my belly, and somebody has to plan for next set of actions. All of this planning these days are done by AI, not necessarily AI agents. So that's an important area. Emergency response is all we know, that we have deep learning algorithm which can, um, like when I was in RPI, my friends here know, I was not there for a long time, but I was paid for a project which was doing uh, essentially identifying blast radius. So when you when there is a forest in fire, how at what height, at what uh, speed the helicopter should be there on the fire so as to spray enough water or the other agents to diffuse the fire. So such kind of thing was done by us using some image processing algorithm, and now those are done by emergency response AI agents. Finance, supply chain, it will take a long time if I explain one after another, but finance is important. Simple important finance is, we all know credit history, credit record is a very funny thing. I feel is in practice. So whether you are credit worthy, that means can I pay you loans? And so different companies use different kind of credit algorithm. So they all have an access. Mind it. This is another way I'm telling you that um, you have to use an API to see my credit report, correct? And when you apply, you give that permission to the company to use the credit report. Now, um, so it calls, it makes some API calls. Now, coming back to whether what does it know? It knows through the LLM that okay, this guy living in this zip code, which is pin code in India, zip code, and at this address, probably has a house which is worth say $500,000. So let us give him a loan, right? This decision is typically done through AI agents nowadays. So again, I'll briefly go through the levels. So the AI agent is asked a question: should Rathi Dasgupta get a personal loan? So the AI agent now uh, asks it sub-agents to work. One sub-agent looking at my credit history, one sub-agent looking at my previous loan paying history, one sub-agent looking at my house valuation, right? And one sub-agent looking at my um, health record. I can take a loan and pass away tomorrow morning, right? So what will happen to them? In this country, you cannot push your loan to your children or your spouse. Not possible. So, I mean, loan sharks have died in this country because of all this socialistic measure by previous presidents. So that's how an orchestration engine works in a finance scenario. Okay, I think I have taken a lot of time. So key takeaways is AI agents is autonomous, tools and memory based. Three operational structures: goal initiation, reasoning, learning and reflection. Agent types, as I said, simple, model based, goal based, utility based learning. React and versus review paradigms, I said, build with governance in mind. Um, Governance is important because an AI agent, and that is not being followed these days. So, one of the major risks of using AI agent for the SOC model I told you, cyber SOC model, was the agents themselves become a threat. Because you understand, your agent SOC is learning the kind of, suppose I built an agent SOC which learns all kind of password spray, malware, um, ransomware, and then brute force. These are four different kinds of threats which happens in cybersecurity. I know the distribution over 20 hours. I know the distribution of uh, threats that's happening coming to this agent SOC, and I know how to create an alert because it's programmed that way. I know how to resolve them. Now these AI agent, if it is malicious, it can send this information to certain other agents that will redefine the threats and will break through this. Recently, as you know, somebody, a young man uh, in Mexico, he used cloud code to enter Mexican government financial department. How? This is how it happened. So governance is extremely important, and there are certifications, but least taken care of. Okay, so I think I've already spent 2 hours. If you guys are still alive or not sleepy hearing, then I'll go to the program.
Rasida,
Huh.
very nice exposition. Uh, do you think, in general, that
Huh.
in future, the AI agents can manage a entire company or even a government? Will that situation come, or will you allow?
I will not support it for various reasons. Um,
Okay.
I'll not support it because of my political bias, but
Mhm.
it can be done. You can have, you need human in the loop. You can create a
You need
policy.
human in the loop, but the entire thing mostly can be governed by AI agents. This can it be done?
Yes, yes and no, Vijay. I'll tell you
Corporate
something.
can be run by AI agents completely.
Uh,
There you
Let's,
don't need any CEO or any these things.
anyways, US are useless. But anyway, forget about that. I've been a
Rati-
CEO in my
Ratida,
lifetime, and
I have
how
one
useless I was.
real question. Perhaps you have clarified earlier, but I missed
Hmm.
it. How sentimental analysis is incorporated by the AI agents?
So, sentiment analysis uh, is a rule-based analysis. Okay, and that has in the AI era that has become a learning based analysis, right? So let me give an example, and I did a very uh, mm, informed research a long time ago. It's a part of the whole corporate structure in a company called Sears Holding. So we identified, I got a note. I mean, I was the problem solver, so I was sitting and probably yawning in the midday, and I got a message from the president of that particular group saying that there's a lot of return of CS products. So my question was, I obviously asked too many questions, being a Bengali. So I asked a question saying, I don't understand. What's CS product? Which products? So, and uh, which of the stores that's returning? Which of the suppliers that supplied these products? Tell me the answer. So he didn't have any answer. So he connected me with the contact center, and the contact center showed me all the different um, um, phone calls for refund, etc., etc. So the first question was, you need to identify what is the sentiment of the customer on a particular product, right? These days it's very easy because you launch a product, they will talk about it in the social media. You can capture the data and you can analyze. Earlier days, in those days, in 2011, 12, 13, when we first started writing machine learning programs for the corporate world, um, and what we did essentially was creating heat map, Kishore. So we are creating heat maps essentially. So heat
Okay.
map means that very simple. I capture uh, three different dimensions. One dimension is product, uh, calls on products. So one dimension is calls on the product. It's like a two-dimensional map which says one x-axis is the products, y-axis is the number of calls I'm getting, right? Second important thing is x-axis is the location, x-axis is the product, y-axis is the location, right? third uh, analysis that I did was x-axis is the product and not product. For each product, x-axis is the reasons for return. Is it broken? Doesn't work? I used it. First time it works, and second time does not work. The package came broken. The package was not correct. And the product was not given to me. It is not the correct product. So many different options. And the y-axis is the number of calls coming in for that. Correct? So that's how. And there was, I think I forgot. There's a tool those days which people were using for sentiment analysis. Okay, I'll tell you that when it comes to my mind. So these were different forms of heat maps which could help people saying, okay, then I found, you'll be laughing if I tell you the reason that's why people are returning. The returning was happening because packaging was wrong. Product, there was no problem with the product. So then my suggestion to these guys were, first you obviously change your style of capturing feedback. Then you change the drop shipper. Drop shipper means somebody who picks it up from the warehouse, drops at the either at the store or at the client's home. Right? Change the drop shipper. Easy, simple. In 1 month, we got 4.7 customer sat. So you need to really pinpoint and change the customer, understand why customer sentiment is different. Now, coming back to the AI framework. So if you do all this input, LLM will obviously create a perception about customer sentiment. But mind it, this is if you look at the time variance of this, and one of the things I'll tell you what I did in one of my previous actions. So if you see the time variance of that, it might change. Today, last week I bought a pressure cooker, Hawkins, from an Indian store. And my wife said, last Hawkins was bad. Why did you buy this? Last one was almost American accent. I said, this will not. Because that is the improvement that has happened. So if you look at, now coming back to the problem that I solved once upon a time, that people are, and this is a problem that Amazon is trying to solve also. Recency. So you can give and as you know, in a marketplace scenario, same product can be supplied by umpteen number of suppliers. Every batch has a different quality. So the customer sentiment should be mapped in such a way that AI agents should be able to match the long-term and the short-term feedback. And sentiment analysis is all about finding the right set of parameters. Those three maps I told you, there are more maps, sentiment maps that you can build and really identify. Right? So you are a professor in a university or a college. Now you can give a feedback form to your students. So how did I do in the chapter on, say, introduction to quantum mechanics? So you will see different kinds of feedback. Now you need to understand how you can capture that feedback. How, to what granularity? So the question is, did you understand my lecture? Was it strong? Was it hard? Or was it too lucid? Did I have, could I communicate the basic reason why quantum mechanics exists? Right? And you can have another question saying, was it too mathematical? Why didn't you like it? Was it the concept fundamentally is hard? Maybe, It was always hard. And was the problem set too hard? The assignments I gave you, right? All different things. And then you can measure the response with respect to those questions to analyze the sentiment. So, to answer your question, yes, you need AI agents which can, in a better way, and there is nothing absolute. You all know that, student of physics. So there is no absolute measure of sentiment. There is the sentiment analysis can only evolve more and more data points that you have. So that way, learning system or machine learning system, which is now called machine learning, used to be called statistical learning and pattern recognition system. So that will improve the outcome more and more. Did I answer your question, Kishore?
Yes, yes, okay, okay, thank you.
Okay. And recently I did a research on, and I'm doing still, with one PhD student, one master student, and friend of mine, Dr. Dural Bhomik at University of Illinois, Chicago, in the psychiatry department, that we were, and my proposal was that there are too many students drop off or commit suicide in America. Why can't we do a simple PHQ 8 questionnaire based assessment of their mental status? And this is what should be incognito, should not be used for any malicious purpose. So we captured about 500 students for this 2025 incoming students, and then my two of my those students, PhD and masters, are solid computer science graduates. The computer science graduates, and they calculated the total score, showed us the total score. Then we said, okay, capture audio, capture video, etc. We did all these three multimodal analysis and captured the total score. Now, okay, before I'll send this if I have time today. So, what they did a very high tech calculation and came back, gave me the total score and area under the curve, propensity, blah blah blah, etc. etc. But my question was, see the first question. What is the first question? Is that how do you feel today? Multiple choice. Extremely happy, just natural, not so happy, little bit frustrated. So these are the four questions. Second question is, did you sleep last night? Somebody says yes, somebody says no, somebody says kind of. Okay. Third question, did you did you enjoy your last weekend? Now there are 8 questions. So my suggestion was, hey guys, you did a mistake. Total score means nothing to me. It can give an overall idea about the guy. Change the paradigm. You should have scores based on cluster of responses to the question. Somebody who has 1, 3, 5, purposefully I picked a number, 1, 3, 5 response positive has a score. Somebody has 1, 3, 5 negative and 6 positive has exactly the same score, but doesn't mean the same person. So basically, have a learning system which will pick up these segment-wise calculation of score and all sorts of combination. These are 8 different questions. We are not considering 8 factorial, but the fact is we can consider at least 100 different cases and see whether that gives you a completely different view, right? And then increase the database, okay, coverage. I captured students with their financial background and students with their immigration status. So paradigm completely shifts. The information completely changes. You will see that immigrants who came on F1 and then living alone, no girlfriend or boyfriend, and then get obviously bullied by the locals, have far more chances of committing suicide. On the other hand, even African Americans living in this country, not well respected, right, by the fellow students, or tortured, or bullied, or whatever it is, becomes absolute bully. So, so these are different. I mean, everything has to. I mean, my point is, the more and more, that's what I chose AI agents. The more and more you have interface with different systems and more coverage of data, you tend to really, really um, create go towards accuracy. You're not fully accurate. You go towards accuracy and uh, can present far more
Rathida,
meaningful data. Yeah.
Rathida,
Hmm.
sentimental analysis shows that attendance is falling. So we should sum up
So I'm summing up
because
because it is already 2 hours.
yeah,
If
yeah,
you
yeah, yeah,
put me into 2 hours of
ha,
conference,
ha,
I
yeah.
would have slept by this time. So by the way,
Okay, okay.
I will. I talked about the PubMed research agent. I have created that. I have. I can show a little bit of the program. So I will close by saying two things. One is I will share the PubMed program. You guys can run it and see how it works. I also have created a explanation of the PubMed agent. You can go through that. And the last thing which I want to say is that the better impact you can make is by joining certain, and I wanted to show you that, joining certain open source initiative. One of them is this one, the website, the open source initiative created by Cisco called Cisco Agent CY, agency.org. So anybody can join and can contribute agents, create agents, and can use on their own. So these are the company's uh, formal members. Cisco is the main, then Google, Oracle, Red Hat. Oracle is notorious, but Red Hat is very good. So this is what I encourage you guys to do. And thanks a lot for a very, very long session, 2.5 hours. You guys are better than me because I would have slept by this time. Thank you very much.
Very nice, Rosida. Fantastic.
Yeah,
Fantastic.
fantastic,
I'll get all
fantastic.
the details later. Yeah, I'll ask you
Yeah, I'll
later.
send everything. I'll send all the
Okay.
files.
Okay. Okay.
I'll
Okay.
send all
Okay.
the files.
Mhm.
Okay.
Thank you.
Thank you.
Thank you, sir. Very insightful talk. Very nice presentation. Any question from audience?
If there is
So
no question, you can definitely reach out to me. I have my Gmail ID, which I will
yes,
share
yes,
it to everybody.
yes,
And
sir.
I'm open to build agents with you guys if you are, or solve some problem. Building agent is a tools work, right?
You can write
But solve some
your
problem.
email address in WhatsApp group.
Yeah, I will send all the files. I think there'll be a lot of good files. You can share with them, and then we
Okay.
go from there. Okay. Thank you, Dr.
Yes,
Pramita.
yes. As we
Okay.
come to the end of this workshop, it's time to reflect on the journey we have shared over the past few days. So your active participation, thoughtful discussions, and enthusiasm have truly made this workshop a success. So a sincere thanks to all the participants. We would love to hear from you. Please share your thoughts, opinions, any suggestions about the workshop. We are happy to hear.
Thank you.
Thank you, sir.
Thank you. Bye.
Audience are requested to share your opinion. As Dr. Pramita said, audience, please share your experiences, share your opinions to make it more glorious, more graceful.
Anybody want to tell anything? Please unmute yourself.
I think we should go for vote of thanks. Naki?
Yes. So before we officially conclude, I think Principal Sir is here with us. Principal Sir.
Hello, hello.
Yes, sir. I would like to invite our Principal Sir to deliver the vote of thanks.
Okay, thank you, Pramita. Thank you. Thanks to Kishore also. So, at the end of this data camp, as organized by the Department of Physics in association with the Department of Computer Science and the Python group, uh, very excellent because though it is not possible for me to present every time, but thing is that the organization of such type of uh, camp on a recent topic for the discussion, for the exchange of uh, views of the this is current subject, very hot cake today. That is a data science. So I first uh, give my sincere thanks to the professors, uh, actually the speakers here. So I'm telling the names. That is the Dr. Kishore Mukhopadhyay of our college, Dr. Urunabu Odhikari, Dr. Obhijit Korgupto, Riti Roy, Dr. Wamit Kumar Chattopadhyay, and today Dr. Rathi Dasgupta. Our college is very glad and excited also. And at the beginning of this camp, or before the beginning of the camp, we were actually in a tension, means hesitate or like that, whether we shall get the sufficient number of participants. But after the registration, we feel that participants uh, joined, a number of professors and also the research scholars and other scientists uh, joined the camp. And I think what is my feelings is that within this short duration, the speakers, I congratulate them. The speakers, the name I have already stated, that in in a very compact way, they have satisfied the audience, and I think on the part of the participants also, that they have uh, also satisfied uh, after the end of this program. So this is a success of the program organizers and the speakers, and of course the participants. Without them, it was not possible to get the grand success of this program. And on the very recent topic, the data science, Python programming, etc., etc., these are the very current topic, and it is the future. It is the future. So, uh, all of you, I think the participants I'm telling, the professors and the assistant professor, associate professor, and the professors, research scholars, and the PG students, all have been all have been benefited by uh, the discussion, lectures delivered during the camp. So there is no words sufficient to give the thanks. I think that you all the speakers, actually we are indebted to all of you, because you have responded, you have taken the responsibility to uh, deliver your lectures, deliver your uh, uh, I think the communicate the knowledge base to all the participants. They have enriched their knowledge base enhanced. So I thank my sincere thanks to all the speakers, and of course the participants, those who have participated, and they are the, I told it already, that they are the means persons of the it is uh, that due to them, we have been able to organize this camp and got the success. So I thanks give my sincere thanks to the speakers. I already mentioned the names, and I think uh, and all the participants. I also give my sincere thanks to them also. And last of all, the Department of Physics, uh, Dr. Kishore Mukhopadhyay, HOD of the Physics Department, and our junior fellow of this department, Dr. Promita Howley. She is also active, but due to her health reasons, she has not been possible. He is not possible to attend the program in every day. I think this, so I don't know. Actually, he has said joined here every day or not. But due to her, I got the news from Kishore that she is in ill health due to the fever or like that. I am not able to attend every day. So, but despite that, uh, her effort, Dr. Promita's effort, I definitely, I congratulate. I also give him the thanks is not sufficient to I think his performance, to evaluate his performance, but her initiative is commendable, and of course the key person of at the highest position of the key persons is the Dr. Kishore Mukhopadhyay. I give him my sincere thanks, not only the sincere thanks, but also I am indebted because of the fact I am the head of the institution. So it is my uh, duty, not only the duty, but also my from my heart I give him my gratitude to him, and also I give my sincere thanks, and again the many thanks to Dr. Kishore Mukhopadhyay, and also the Department of Physics and the Department of Computer Science and the Python group. With these few words, I give sincere thanks to all, and I welcome them in the sense that at the end, because in future such type of camp or the seminar or the conference will be held, then again I request to the Department of Physics to invite all of them uh, for participation, not for delivering the lecture and for participation. With these few words, So I'm indebted to all of you and give my sincere thanks to all of you. Okay, it is the it is the end of this program. Dr. Kishore may say something. Kishore, you say if you want.
Uh,
No,
uh,
Promita, thank you, sir. Promita will conclude the session.
Thank you, sir. Thank you for your appreciation. Sir, it was totally a team effort from our department. So, finally, we would like to thank each one of you for your active participation. It's been a wonderful learning experience together. And there is an announcement about the certificate. So, a feedback link
Yes.
will be shared in the WhatsApp group. So, you will get the e-certificate after filling it out the form. So, don't forget to share your valuable feedback and complete the feedback form. So, looking forward to seeing you again in our future workshop. Keep learning. Thank you, everyone. Good night.
Thank you. Thank you, everyone. And good night, all.
Thank you.